In this lesson, we will be starting chapter 13, acceleration. It might not feel like it as you're sitting in your chair watching this video, but you are moving. You're always moving. And this is because the Earth moves at a constant speed of 30 kilometers per second around the sun. We don't feel the movement because the air moves with us. Movement is more noticeable when motion is changing. That's what we're going to be looking at in this chapter. You should recall that velocity is change in displacement. So you should recall that velocity is change in displacement. So velocity equals change in displacement over change in time. So it's really the rate of change in displacement. So velocity is the rate in change in displacement. Whenever speed is increasing or decreasing, or velocity is increasing or decreasing, the object is accelerating. Acceleration equals change in velocity over change in time. To write this as a formula, the symbol for acceleration is small a with an arrow over it because it is a vector quantity, meaning it has direction. So acceleration equals change in velocity. This little arrow means change in, or this little triangle, over change in time. So to write in what those symbols stand for in the formula, acceleration equals change in velocity over change in time. We'll be looking at a couple different types of acceleration. Acceleration from rest. When an object accelerates from rest, then the initial velocity, or what we call v1, equals 0. Just back to purple. When objects are falling, then their acceleration is due to gravity. And the average value of acceleration of gravity on Earth is 9.8 meters per second squared. The units for acceleration, and I should have mentioned this up here, because it's velocity over time, so it's meters per second, or what we more typically write is meters per second squared. It's the change in velocity every second. So meters per second every second. This value, this 9.8 meters per second squared, doesn't apply to objects that are affected by air resistance. Objects that have a large surface area have a large air resistance and will not accelerate due to gravity at the rate of 9.8 meters per second squared. They'll be slower as they're slowed down by air resistance. We will also be looking at negative acceleration, and this is when an object has a decrease in velocity and it is said to have a negative acceleration. So for example, if a car is traveling east and it starts slowing down, then we could say its acceleration is negative 5.6 meters per second squared. It's slowing down in the east direction. Or we could say it's 5.6 meters per second squared, and this should be west. So it's speeding up in the west direction. Also in this unit, we're going to be looking at graphing. And we're going to be graphing, instead of distance versus time or displacement versus time, we're going to be graphing velocity versus time. So here's a velocity versus time graph of a vertical projectile. So that's an object that is shot straight up in the air. And what's going to happen, of course, is that the object, if we just drew a picture, this is where it's, I don't know, say this is a cannon. So it's shot up. The object is going to go up to a certain distance. It's going to slow down. It's going to stop in midair. And then it's going to fall back down. So the graph of this would look like its velocity here initially, as fast as it's ever going, is right when it leaves, right when it's being shot up. And then the velocity will decrease. So this part of the graph is showing a decreasing velocity. It is slowing down as it goes up. Right here, right where it crosses this x-axis, its velocity is 0, is where it stops in midair. And then as it starts falling, it will have an increasing velocity. And you can see that here the velocity is increasing as it moves down.